A new video. And I want to this in this video to explain to you to complete on press first search. And press first search, as I told you before, it was a search, and search is about taking a steps, and every step you ask yourself, is this the goal? And if it's not, you move a step again. And okay, and press first search is about the idea of queue, and in nutshell is about people standing in the queue, and the first one who came first, okay, will move first and have his enters first and purchase first, for the for example the ticket or anything, right? Okay, until the queue has no one left. Okay, or until we found our goal. In this problem, we want to use the breadth first search to make the computer find for himself, by itself, the shortest route, shortest path to reach 36. Okay, I want you to say something. I want you, to say to you something that bef- without snakes and without ladders, can we reach 36? Yep, alright, we can. Okay, the shortest and the only path will be is that we have to move pi every square until we reach 36. Alright, okay, but here we have utilities to use. We have ladders, which makes you move upwards, and we have snakes, which makes you move backwards. Okay, if you got in the first ladder, you will end up at the end of it. So if we are in square one and we move only one step, okay, from this one step we'll end up into 15 just from one step. Okay, right. And if we are in square 15 right now and we move only two steps, will end up into 17, but actually will end up into 13, because if you got into the face of the snake you will end up into its tail. Okay, considering this, can we find the shortest path to 36? Can computer make the computer, considering those facilities, considering um, those things we can utilize to reach to 36 as fast as possible? Or it's not about time, we can say it's about the shortest path, the shortest route we can move. Okay, I want to say that from the first glimpse, you can say it by yourself or guess it by yourself and found by yourself the shortest route to 36. Okay, you can say I can move from one step here and I will reach from one step only 15. Okay, and got there, but you will end up into 13. So what's the point? Okay, computer can figure out this by itself. And how is this? Remember the idea of the queue. Okay, we start into one, so we will use the idea of the queue. Okay, so now we have only one. Okay, and one is not the goal, so we remove out and process on it, move the steps. And the steps here in this problem, in this context, it differs, but the same concept. Okay, but steps here is translated into rolling the dice, and we have to roll the dice from square one to move steps. But okay, so here we have to roll the dice and move steps. The thing is that we are not sure, we are not certain about the results of rolling the dice, because it could be four, so we'll move four steps, so we'll end up into five. But that's not only the case. The case could be into it will end up into one, so we'll move into square two. Okay, and because we don't know for sure the result of rolling the dice, we have to simulate, to consider the six possibilities, all the six possibilities from square one. And from square one, we will consider the six possibilities as I wrote here. Okay, there are six persons waiting in the queue, which are square two and square 3, 4, 5, 6, and 7. Why? Because those are six persons, which are the six possibilities of rolling the dice from square 1. Alright, okay. Why we did this? Because as I told you, we are not sure the results of rolling the dice. It could end up of one of those, of 2, or 3, or 4, or 5, or 6, or 7. You got me? Okay. And 2 came first, okay? So we'll do the same as 1, okay? Now, the 2 are in the queue and it came first, so we'll ask her, and it's not the goal, so we'll consider its neighbor, which are the six possibilities, the thing that exactly we did into square 1. We will roll the dice, we have to move steps, okay? The six possibilities again, okay? Which are, it could end up into square 3 or 4 or 5 or 6 or 7 or 8. Alright? Okay, because 3, 4, 5, and 6 and 7 are already in the queue, we will not write them again, because in real life the queue, you can't be duplicate into the queue. You are just one version of yourself. Yeah. So exactly here we cannot replicate 3 twice in the queue. Okay, so because they are already written, we will write only 8. Okay, why? Because 3, 4, 5, 6, and 7 are already written. Okay, so we'll write 8. So 8 will stand in the queue, and 2 will be a dropout, or will be kicked out, and 8 now is the new person. Alright, and here 3, the same thing. 3 will add 9. Why will not add 4, 5, 6, and 7, and 8, and 8? Because they are already in the queue, so we'll write 9, and the same thing until we reach 36. But there's a thing here that we are not considering, the idea of snakes and ladders, because on the same as we follow up this method, we will move 36 steps, and we will pass by every square, so it's a very long route. We will have to move 36 steps. You got me? Okay. But the thing is that we have to make the computer consider these facilities, these utilities, which are ladders and snakes. Okay, so 2 here has a ladder which will end up it into 15. Okay, so instead of that, we say okay, we say that 2 is really 15 and not 2. So 15, and here 3. So it's a 2, but it's not actually 2, because um, it will end up into 15. So this 2 is not actually 2, it is 15. And here comes the interesting part, right? Because we here in 15 will consider the neighbors of 15, the possibilities of 15, which are 16, 17, 18, and 19, and 20, and 21. And those neighbors will come before the 7. Why? Because 3, 4, 5, 6, and 7 were the neighbors, or the possibilities from square 1. But 16, 17, 18, 19, 20, 21 are the neighbors from square 2 or square 15. Okay? And square 2 came after square 1. So those will be before square 7 in the queue. Okay, so now we don't have this 2 and this 15. We only have these possibilities, its neighbors. Okay, and now we have this. Now we have this in the queue: 3, 4, 5, 6, and 7, and 16 until 21. And we'll do the same. 3, we will kick it out and consider its 6 possibilities, which is 4, 5, 6, and 7, and 8. Okay, 8 will come here. Why? Because 8 is a result of possibilities of square 3, and those 6 are the results of considering the possibilities from square 2. So square 2 came first, they came first. So here 8 will be 8 and 9, the possibilities from considering rolling the dice from square 3 will be 4, 5, and 6 and 7, which are already written, and 8 and 9, the result will be before 21. And we'll move this, we'll keep repeating. Okay, we kicked out 3, and it's time for 4, the same thing. 5, 6, and 7, and 8 and 9 is already written, so we'll write 10. Okay, 5, 6, 7, 8, 9, and 10. Yep, and the same thing for 5, same thing for 6, and so on. And 16, and the same 16, which will be result of 17, 18, 19, 20, and 21, and will be 8 and 9 and 10 and 11. 10 and 11, that's the result from 6 and 7. Okay, and there will be I think 12 also, and this 16 will have 17, 18, 19, 20, 21, and 8, 9, 10, 11. I think there will be 12, 12, and 22. Why 22? Because it will because it's 8 and 9 and 10 and 11, and if 12, as I saw, I think they came first, so 22. And I think that you start to get the point of considering how computer will consider the idea of snakes and ladders. Okay, until we got here into 17. When we got into 17 and consider its neighbors or its possibilities, which are 18, 19, 20, 21, and 22, it will be 20. I think there's 2, and there's 2, and 22, the third. So there will be 23, okay? And 23 will be as the last one, okay? But the thing is, here in 17, the neighbors will not be 18, 19, 21, 20, 21, 22, and 23, because actually 13 here is 17 here is 13, the same thing as in square 2. Okay, because 13 sorry, 17 as the face of the snake. Okay, so it will end up into 13, right? Okay, so instead of 17 it will be 13. So it's 13 disguised as 17. Okay, from 13 we consider neighbor, which are 14 and 15, 16 and 17 and 18. Okay, the thing is here 17 is written before, so we'll not write it again. Okay, so 14, 15, 16, 17, 18, and still 19, and they will all stand before 22, as you remember, because 22 was the last one that resulted from rolling the dice from square 16, and that's how it gets. Okay, I know if I continue um, estimating it and calculate it, it will be out of hand. But we get the point. Okay, the thing is that we get the point, we get the idea, and we make the compute. When we make the computer handle the rest of it. Okay, okay. Because if I keep continue solve it, it will get out of my hand and it will get very big for me, very big scale. Okay, but we give the computer the intuition, and computer can handle it for us. Okay, I think you get the point. So here from to just to wrap it up, we start from square one, and square one is not the goal. So we consider it six possibilities, which is 2, 3, 4, 5, and 6 and 7, simulating the six possibilities in real life of the rolling dice. And from square two, okay, it will be actually 15. Okay, so we'll consider from 15 and so on and so on. Okay, until we get into 36. The shortest path will be, however, will be computer will move this and we'll get into 15 from the first step. That's the first step, and we'll move there. Okay, that's the second step. It will end up into 17, but actually 13. Okay, because the snake, and it will move one step again to end up into 14, which will end up into 35. That's all from the third step, and the fourth step is to move one step into 36, so the total is 4 steps. That's it. I hope you get the point, and I hope you understand it, and thanks for watching.